Hello my dear students! Welcome back to our new science visual lesson. Once again, I am your science teacher, Teacher Larry, and welcome to a new day of learning. We are now at our first quarter, Module 5 in Science 7. So brace yourself as we explore the wonderful world of science. I am very excited to bring you today's lesson all about concentrations of solution. Keep watching because at the end of this video, you will be expected to express concentrations of solutions quantitatively by preparing different concentrations of mixtures according to uses and availability of materials.
Specifically, you are expected to describe the concentrations of solutions quantitatively, explain the difference among percent by mass and percent by volume, solve problems involving different expressions of concentration of solution. In our previous lesson, you have learned all about solutions. And when we say solutions, it has two components. We have the solute and the solvent. When we say solute, it is the component of solution which dissolves or the component present in a small amount. And solvent, it is the component of solution which dissolves the solute or the components that comes in a greater quantity. You also learned about solubility, and it is defined as the maximum amount of solute that can be dissolved in a certain amount of solvent at a certain temperature, or it is the ability of the solute to be dissolved in a solvent. There are two types of solubility. When there is a less amount of solute dissolves in a given amount of solvent, the solution is said to be unsaturated. But when there is a maximum amount of solute dissolved in a given amount of solvent, then the solution is saturated.
The question is, how do we know the accurate amount of solute in a solution?
When we say concentration of solution, it refers to the amount of solute relative to the amount of solution. Did you know that we can express the concentration of solution in two ways? Yes, we can express them by qualitative observation and quantitative observation. When we say qualitative observation, this refers to the descriptive details about observation using your senses, while quantitative observation refers to details about an observation that quantify the observation using numbers. Examples are measurements.
For example, you prepared a cup of coffee and you put too much coffee on it. What do you think will happen to the color, taste, and smell of the coffee? Yes, the color of the coffee will be too dark, the taste of the coffee will be bitter, and the smell of the coffee will be too strong. The intensity of the color, the degree of bitterness, and the strength of the smell is an observation under qualitative observation.
When there is a large amount of dissolved solute for a certain volume of solvent, the solution is concentrated. And when a solution has a small amount of dissolved solute in comparison to the amount of solvent, this is said to be dilute. Dilute and concentrated are only relative or qualitative observation. A more accurate way of expressing the amount of solute in a given amount of solvent is in terms of quantitative observation or by percentage. Concentration of solution can be expressed quantitatively by percent by volume and percent by mass. When we say percent by volume, it is the amount of solute in a given volume of solution. And percent by mass is the amount of solute in a given mass of solution. Percent by volume can be expressed as the volume of solute present in 100 milliliters of solution. And percent by mass can be expressed as grams of solute per 100 grams of solution. Mathematically, we can express percent by volume by volume of solute over volume of solution multiplied by 100, and percent by by mass of solute over mass of solution multiplied by 100. Labels of product we use at home often shows the concentration of solute expressed as percent of mass or volume. For example, the alcohol we use as disinfectant is a solution of 70% isopropyl alcohol, meaning it contains 70 ml isopropyl in every 100 ml solution. Vinegar is labeled as 5% acidity, which means it contains 5 grams of acetic acid in 100 grams of vinegar. Gold is often referred to us as carat. Pure gold is referred to us as 24 carats. A jewelry that is said to be 18 carats, meaning it contains 18 grams of gold for every 24 grams of materials. The remaining 6 grams consist of the other materials like copper or silver. This means 18 karat jewelry has a concentration of 75% gold.
This time, let us put into application all that you have learned all about concentrations of solutions. You can pause this video to challenge yourself in answering the problem. Let us begin.
Problem number 1. What is the percent by mass of a salt solution by dissolving 11 grams of salt in 80 grams of solutions? Before we try to solve the problem, let us identify first what are given, what is being asked or required, and what formula we are going to use. In this problem, we have 11 grams as the mass of solute and 80 grams as the mass of solution. What is asked is the percent by mass. Therefore, we will use mass of solute over mass of solution multiplied by 100. And we will now have our substitution or the solution. percent of mass is equal to the mass of solute is 11 grams divided by the mass of solution is 80 gram and multiply by 100. So we will cancel the unit, which is the grams. 11 divided by 80 is 0.1375. Multiply by 100, it is 13.75%. So our final answer. Problem number 2. What is the percent by mass concentration of a sugar solution that contains 8 grams of sugar dissolved in 15 grams of water? Before we try to solve the problem, let us identify first what are given, what is being asked or required, and what formula we are going to use. In this problem, we have 8 grams of sugar or the mass of solute and 15 grams of water or the mass of solvent. What is being asked is percent by mass. Therefore, we will be using the formula percent by mass is equal to mass of solute over mass of solution multiplied by 100. To solve the problem, we are going to substitute what is given to the formula. So we have percent by mass is equal to the mass of solute, which is 8 grams, over the mass of solution. Notice that the problem does not give the mass of solution. Instead, it gives the mass of solute and the mass of solvent. To get the mass of solution, we will going to add the mass of solute and the mass of solvent. Multiply by 100. Therefore, 8 grams over 8 grams plus 15 grams is equal to 23 grams multiplied by 100. We can now cancel the units. 8 divided by 23 is 0.3478 multiplied by 100. 0.3478 multiplied by 100 is equal to 34.78%. Our final answer. Problem number 3. How many grams of sodium are present in 250 ml salt solution containing 9% sodium chloride? Again, before we try to solve the problem, we must first identify what are given, what is being asked or required, and what formula are we going to use. The given in this problem are 250 ml salt solution or the mass of the solution, and we have 9% concentration of sodium chloride. What is being asked is the mass of solute. In this problem, we cannot simply use the formula percent by mass is equal to mass of solute over mass of solution multiplied by 100. Instead, we will derive our formula. To solve the problem, we will now substitute what are given to the given formula. we have the percent of mass, which is given as 9% sodium chloride, equals to mass of solute, which is being asked. So we will let X be as the mass of solute over the mass of solution, which is 250 ml. In this equation, multiplying the ratio of solute and solution by 100 will not be applicable because the percent concentration is already given. So we will copy X over 250 ml, and we will write the 9% sodium chloride by mass of sodium chloride solution, meaning there is 9 grams per 100 ml of solution. Now 9 divided by 100 is equal to 0.09 gram per ml, is equal to, just copy, X over 250 ml. Then we will be multiplying 250 ml both sides. We will be multiplying both sides. In this, to remain X only, we will cancel 250 ml in this side of the X, and the units in the other side. Then we can now write this as 250 times 0.09 gram is equal to X, or X is equal to 250 times 0.09 grams. And our final answer will be X is equal to 22.5 grams. Problem number 4. A salt solution contains 50 ml of ethanol in 300 ml alcohol of solution. What is the percent by volume concentration of the solution? Again, before we try to solve the problem, we must first identify what are given, what is being asked or required, and what formula we are going to use. The given are 50 ml as the volume of solute, 300 ml as the volume of solution. What is being asked is percent by volume. The formula that we are going to use are percent by volume is equal to volume of solute over volume of solution multiplied by 100. To solve the problem, we simply substitute what are given to the formula. We have percent by volume is equal to volume of solute, which is 50 ml, over the volume of solution, which is 300 ml, multiplied by 100. We now cancel the unit. 50 divided by 300 is 0.1666 multiplied by 100. 0.1666 times 100 is equal to 16.66%. That is our final answer.
Congratulations everyone! We are now done in our lesson in Module 5. I hope I was able to help you in understanding your science lesson. Once again, I am your science teacher, Teacher Larry, and see you in our next video lesson.